Webinar recording notice. This training session will be recorded. If anyone objects to being recorded, please drop off the line now. Thank you. What we are going to do today is we are going to actually make examples of SNAP programming. First example we're going to make is a program augmentation to our outdoor lighting routine. If you were to go into Application Builder and create an application, go down to the Universal Controller and actually select the outdoor lighting program. As you can see, all we have on run conditions is sunrise and sunset. What we're going to do to augment this program is we're going to actually set it up to run off a BACnet schedule. If I were to load this application, which I've already done inside of iView, as you can see, we're currently running at 16:02, and the sunrise occurs at 6:42 a.m. and sunset occurs at 20:47. What we can do is we can actually override the sunrise sunset if we go down to the Properties page, Equipment Files, and go to Output Control. Inside of the Output Control, there is an on-off auto. If you go in there and you look, there's an auto and then there's a lock. Now, when you enter the lock, you can actually lock the unit on or off. So what we can do is we can write an output to this on-off auto and toggle it back and forth to be on or off. So that'll take we're going to actually have to write out to this point. So, first thing, so we need 2 points. That's what we need to do. So if we go into Snap, the first thing is we're going to put in an occupancy schedule because we want it to run off an occupancy. After that, we're going to have two BACnet parameters. One's going to be the locked, and the other one's going to be the toggle for on-off. Now I'm going to make these BACnet points because I want them to actually be network visible, and someone throughout, let's say if they wanted to write from an existing third-party system, they could actually toggle this on-off. So if I open up the program, or one of the properties, the first one I'm going to make it as a override. So this is going to be off or on. Toggle. Now this this parameter is going to be a manual override, just in case we want to just make it so we change this to on and it turns the lights on. The other thing we're going to do is we're going to actually make it so the schedule microblock will actually turn it on or off. So I'm going to make this inactive, leave it as inactive text as off, and I'm going to make this network visible. Now the other one, the other BACnet parameter is going to be locked. So I'm actually going to call this locked. And I'm going to make this active because I want to take control of the lighting routine. So the default value for this is I'm going to make this active. And I'm going to change the inactive text to auto. And I'm going to change the active text to locked. And again, I'm going to make this network visible. Now, to write a program over to another program, we're going to actually have to use network points. So if I go to my network points section on the B&O writes, I'm going to have two network points in here. Now the bottom one, I'm just going to draw a straight line over. And actually, that's going to go directly out to that B&O. The other one is I want to actually do an occupancy schedule, or I want to actually make it override. So I'm going to do some logic in the middle of it and actually put an OR microblock. If I put the OR microblock and then I drag over to the OR, that would be, it's going to be this if this is on, or if the occupancy is on. Now I don't technically want to actually write the or draw a line directly down to the OR. I want to use a label. So I can drop a label in by taking this and actually typing OCC. And the top of the occupant schedule is always the toggle. The other one, which I can drop a label on that, I'm going to call it 4, is the time to next schedule change. And that's used with our set point microblock, or if you're using the runtime microblock or something like that. Now, I can take another label and drop it right here and reverse the direction, but if I don't name it the exact same thing, like let's say I named it an underline or a lowercase, it's not going to be correct. A better way to do that is actually click on the OCC, the label right here, copy it, and then paste it. And as you can see, it is under my mouse, and I can click it and add it to wherever I want. Now I have to reverse the direction of this, so I go in, open it up, and actually reverse direction to input, and I drag it over here to the OR microblock and drop it on that. Now you can use these occupancy throughout your programs if you want to, and actually there could be multiple inputs, there can only be one output. So the other side of the microblock, or the OR microblock, I'm just going to drag it and drop it over to the other B&O. So now we have two different ways to actually schedule our B&O microblock. So I'm going to open the B&O microblock up, and I'm going to name this on, off, value. I'm going to come back to the address here in a minute. I'm just going to name this. Now you can change the refresh time to 1 minute or 10 seconds depending. 1 minute is pretty much the default. So if I go to the other B&O microblock, I'm going to call that the locked microblock. And again, you have your on and active text, and I can make this auto or locked depending. The refresh time is 1 minute. And if I want to show these BACnet network points out on the property page, I can check that, or I can uncheck that if I don't want someone to edit it there. So I close that. So this is our basic program, but we don't have the addresses for these B&Os. So what we need to do is we need to go back to our Internet Explorer page or our iView Open System and figure out what we need to do for the addressing. Now I'm going to add this program into the same program, the same equipment. So what I can do is I can use BACnet:// So I just need to know the points. So the first one is is the lock point. If I control click on it, it will bring up the property for it. If I go to the details tab, at the very bottom you see that it's network visible, and we have a man_override_1. That's the actual object name that you can use. You can also use the object ID, which is binary value 1. So you can use BV1 or man_override_1. So I'm going to copy this and switch back to the snap program. Open up the locked values. Now, my address always starts with BACnet://. As long as it's a BACnet point, that's what you're doing. If it's Modbus or something else, you will actually have to change that the beginning of the address. So I'm going to use this BACnet:// this, and I'm going to paste in man_override_1. So that's the address that we're actually going to talk to with this locked value. So I've done that one, so I need to go back to the actual application in Internet Explorer. If I control click on it, on the other one, which is the locked units, which is the toggle, and I go under details, I've got a man_override_value_1. So I'm going to select that. Go back to Snap. Open that up, and use the same addressing functions. I'm going to use BACnet:// this / man_override_value_1. So now I've created a program, simple program using 6 microblocks. The other thing I want to do with this is I want to do some trending. I want to see when they actually it goes occupied or if somebody overrides it. So what I can do is I can put up a digital trend log. If I go to the log section of this, and I can just hang the digital trend right here. I'm going to name it lighting, on, off. And you can set up your trending. If you want to enable trend logging, you can allocate memory for it. The sample every, you can actually enable historical trending inside of it. And then you can use the system setting or set it up to keep historical trends for so long. So once I've done that, I need to actually draw the wire over. I can't just come to the middle of the wire and draw a wire. I have to actually come over to the side, grab the wire, go up, turn it, and then go into the lighting on off. So now I have a trend, I have an occupancy, and I have an override for the occupancy. I'm going to save this, and then I would load it into the iView server. Now I've already done that, so I'm going to actually switch over to the Internet Explorer, which is the iView server, and I'm going to go over to Schedule Override. Now as you can see, I haven't set up any of my properties. If I were to set up those up, I would actually have to go and create the text microblocks, but I'm just going to leave it like this. And if I go into network points, I'll actually see that here's my backnet : /this/man override and then manual override value. As you can see, the locked value is on. However, we are in the off position. So if we go back to the lighting routine, and we get here, we can actually see that the lights are off. If I come in here and if I wanted to write a schedule to it, as you can see, the schedules right now, which is set up, is 6 a.m., midnight to 6 a.m., and then 6 p.m. to midnight. If I wanted to actually set it up to see the toggle right now, I would come in here and I can actually add another normal schedule. I'm just going to make it a weekly schedule, weekly, on Wednesday, and I'm going to hit OK. That's going to download that schedule to this UCXP. And if I go back to the Properties section, you'll see that the actual on-off value is now on. If I go to my outdoor lighting routine, I have the lights. And now you can actually command the lights on and off for a school or something like that if you're using a schedule, using a backnet schedule instead of using the sunrise to sunset calculation. All right, I'm going to go ahead and just select all of these and delete them and create my next application. The next application I'm going to create is, in some cases, there are more than one VAV box that actually services a particular room. You can have a classroom 1 that might have, let's say, a classroom that had 2 VAV boxes or even 3 VAV boxes. Now, if we're going to do CO2 in those, you can actually share the CO2 sensor between them all and not have to wire up a VAV box with a CO2 sensor for each program, for each controller. What we do is we actually do a snap program to send the CO2 point from one VAV box to another VAV box. So here's what I got to do. We go into Internet Explorer, and let's say I go into the VAV box, the single human resources. If you look, the first one right here, this is the status. It's 1,000 parts per million. That's the point we're going to read. So if we go to the other one, the VAV single duct, and we expand it, we'll actually see the values that we want to write to. We actually have to lock the value, and we have to enter the parts per million. So we're going to need a B&O. We're going to need an A&O to write out. We're also going to need an ANI to actually read the indoor air quality from the other VAV box. So I'll go in, and I'm going to actually drop in an ANI microblock. Let's say we'll call it Classroom 1 sensor. I'm going to leave the address just as is right now. And I'm going to drop in another one, which is an A&O microblock. And I'm going to call this Classroom 1 East. Now, we're going to have to actually do a B&O out on this because we needed to write out the locked value too. However, we don't have a B&O on this actual snap program. So what we can do is we can use a digital to or an analog to digital converter. And if we go in here, we can actually put in, we can put in this microblock, which will actually convert this analog signal. If I draw the wire over, and then draw one to here, off the wire, it'll actually convert it to a discrete output. Now, as long as we are not sending a 0 value, which CO2 never goes down to 0 parts per million. So as long as we're not doing that, it's not going to actually, it'll always send the value from the one CO2 It'll actually always send that output. And if you look right here, you can see that an analog wire is a solid line, and a binary wire is actually a dotted line. So that's you can actually tell which ones are analog and which ones are binary. Now you cannot put a analog into a binary point. You have to do a conversion or something like that. So what you do is you use this analog converter, or you have to make sure that you're not doing making any errors in your program, because you will actually error if you do that. So I'm going to go back to my program. I'm going to go to my human resources, and I'm going to go into the control-click on that status, and I'm going to go under details, and I'm going to actually say, okay, I need to pull in the object name of IAQ, and it is network visible. That's something you have to have. If you do not, it will not work. You close that. I'm going to go back to my Snap application, open up the Snap application, and I need to know the device instance number, which in this case it's 1617024, and then paste IAQ. So I'm going to pull that from the device instance number, and I'm going to send it to, or I'm going to pull it from the device instance number 1617024, and I need to actually know what I'm actually going to send it to. So if I go back to the actual program and go to the VAV single duct, I can go under here, control-click, and this is the override. So I'm going to make this one network visible because it is not. Since it's not, it wouldn't be able to write to it. And I would put IAQ override. Copy that. And then we're going to send it over to 1617025 slash, oh, I'm sorry, 1617025 slash IAQ override. Oops. That's actually going to be in the binary. Pardon me. 1617025 slash IAQ override. If I go back to my Internet Explorer page and I control-click on the value, it's going to be network visible IAQ override underscore value. I'm going to copy that, and I'm going to actually put that into the ANO override value. So now I'm actually taking the CO2 from one system and actually sending it out to the other actual CO2. So I can actually pass the CO2 between two VAV boxes, or if I wanted to, I can actually make it so I can pass it to another one, or if I wanted to do a completely different CO2 sensor, I can select all of this, copy this, and paste it. So you can actually do multiple VAV boxes in one equipment file and not have to actually create an equipment file, each equipment file per that. All right. So now that I've done that, that would be a CO2, passing CO2 between two VAV boxes. I'm going to go ahead and delete this, and I'm going to do our last equipment file. Now this is a bit more advanced equipment file. We're actually going to use the BACnet PID microblock, and we're just going to read a temperature and a fan status and ramp our PID microblock depending on what the temperature settings that we have for it and if it's occupied. So the first thing I'm going to do is I'm going to put in an occupancy sensor because we're going to need that. And again, I'm going to put my labels. I'm going to put my labels as OCC. Put my other label as 4. Now, I'm going to actually have to use physical analog inputs, so actual inputs on the actual board. So I'm going to go over to my I/O point section, and I'm going to use an AI. If I open that up, you'll see that I have display name, all sorts of different things. What I'm going to call this one, I'm going to call this temp sensor. And I'm going to actually leave the hardware configuration blank. You can do this in Snap if you want to. You don't have to actually give it the input that it's going to use. So in case you reuse this program, you can just go back and actually change the inputs as needed. You can give it a number and an expander number if you know exactly which one you're going to use. If you're going to do that, just make sure that you are certain that you're not using that input inside of the universal controller or app controller, because it will actually have conflicts if something else is using it. So I'm going to leave the expander number 0 and input type as 0. I'm going to leave this as not network visible. I do not recommend having someone being able to read a physical AI. I prefer that you have a status microblock going over that they would actually read the status of that. So I'm going to leave this blank. Go ahead and close that. The other one I'm going to use is I'm going to use a binary input. I'm going to open that up and I'm going to call that fan status. Again, I'm going to leave this blank and I'm going to leave it as not network visible. And then, since we are going to need some statuses on this, I'm going to actually go to the System Out and go to the Status microblock. And this is a binary status, and the one below it is an analog status. So I'm going to drop those in there and draw the wires to each. I'm going to call this one Temp Sensor Status. And I'm going to call this fan status. And I'm going to leave these network visible in case someone wants to come in and actually physically read those. Now the next thing I'm going to need is I'm going to actually control the fan by temperature and by occupancy. And I'm also going to give it a lock value so I can actually turn the fan on as needed. So I'm going to use a BACnet binary output. Put it right here. And I'm going to name it fan off, on off. Now, coming into that, I have a couple different things I want to do. I'm going to take the temperature and I want to read it in here, and if it goes less than 85 or greater than 55, I'm going to actually turn the fan on. If I want to do an override, I'm going to put an override in here, and I'm actually going to control it as occupancy is needed. So I'm going to hang a label off of the temp sensor. I'm going to call it temp. I'm going to copy this, and then reverse direction. And I'm going to have it going into two if statements. One of them is going to be if greater than or if less than. Now, I can use this as putting a constant inside of here and putting the trip point as, call this 85. I'm going to call this 55. Now, if I wanted to actually have a variable that you could change, you would actually use the other microblocks below it. And as you can see, they're a little bit different. They have two inputs on the side instead of just one. And you can actually make that a variable, and you can actually change the variable as needed. But since I know what the values I'm going to use, I'm just going to use these ones. So I'm going to wire the temp sensor to the 1. I'm going to actually create it so it goes down and actually goes down to the other microblock. Now the other thing I wanted to use is I want to use just an override, just in case I want everything to turn on, because sometimes you just need to. So I'm going to have this one as override. And I'll make it inactive, and I'm going to make it network visible. Now you can change the network visibility inside of the iView Open System or the Field Assistant. The only reason why I'm making it network visible now is because usually you want that to somebody to write to it. But those are default values, so you can change that as needed. And the last thing I want to actually do is I want to actually take the label for occupancy. I'm going to put it down here because I want to control off occupancy also. So if it goes occupied, it's going to turn the fan on. Now how do I bring all of these variables in here and just into one BO? Well, what we can do is we actually have, inside of logic, we have the ORs. Now I used a 1 OR before, but you can actually you have a 3, a 4, or even a 5 OR if you need to. So if any of those actually turn on, then it's actually going to turn the binary on. So I'm going to use since we have 4 different inputs on there, I'm going to use the OR 4. Put it in there. I'm going to drag the occupancy into the first one. Now you can just actually attach the labels directly into those. The next one I'm going to actually put into the top wire. And then I'm going to create this one and put it into the next wire. And the override, I'm going to put it into the last one. So now I have fan on and off. And it's going from the temperature, if it's greater than 85 or less than 55, if it's occupied, or if you have an override, it's going to turn the fan on. So the last thing is we actually want to create a BACnet PID microblock that will actually open valves, since we might have some hot water or something like that we would want to use. So if you go under the convert section, you have a BACnet PID direct acting or reverse acting microblock. You can actually set it to be reverse acting if you need to. What you do is you go and open it up and go into here, and you can actually set it to be reverse if you want it to be. So I'm going to close that. Now the first thing is I want it to actually turn on with the fan status. If the fan is on, then it will actually start doing the valve. I don't want it to turn on unless the fan is on. So I'm going to hang another label off here. I'm going to call that enable. I'm going to hang it off the fan status. And I'm going to switch to reverse the way to go. And then put it into the go section. Now there are optional inputs that you can actually select in here, and you can have all of your proportional, integral, derivative, all that stuff can actually be as an input. But we're just going to use the basic PID microblock and not actually do those. So first things first, I have my go. Now my set point, I'm going to have it control off 2 different set points depending on occupancy. So the first one is I'm going to have it, I'm going to put in 2 parameters. One's going to be an analog parameter, a BACnet analog parameter for occupied, and then a BACnet analog parameter for unoccupied. I'm going to put in here, I'm going to put unoccupied set point, and then occupied set point. And again, I'm going to make these network visible because they are parameters, and someone can write to them over the network if need be. Now, how do I switch between these? Well, we have what's called a switch microblock that's actually in the relay section. You can actually put in here, you can actually use the switch microblock, which has 2 inputs that will go to a set point, or send that value out depending on a switch. So I've dropped that in there. Now the switch is going to be the occupancy, so it's going to be the on-off on there. So I'm going to open that, reverse the direction, put that into the switch. Now these values I'm going to use, the first one I'm going to use as 74. The other value I'm going to use 68 for occupied. So by default, the switched value, when it goes occupied, and I need to reverse these because that would be the top one. I take that back. It's going to be, this one is going to be the unoccupied, so that's the unoccupied. So when it's not on, it's going to use the 74 degrees. I'm going to put the 68 right here and have that go into the other one. So when this goes active, it's going to switch to the 68 degree set point. Now, I'm going to have this, and I'm going to send this into here. So it's going to control to this set point. Now, how did the BACnet PID microblock know what it's going to control to? Well, we had created the temp label up here. We're actually going to use that again on the input so it knows what it's actually going to control to, and that's the in. So I'm going to reverse this and drag that into the in. Now this is going to do a 0 to 100 output, and I need to convert that to a 0 to 10 volt analog output for a valve. So what we can do is we can actually go in here and we can use a, a ratio C, and if you open that up, the input would be 0 to 100%, and the output is going to be 0 to 10. So my output is going to convert from 0 to 100% down to 0 to 10%. So when I use an analog output, I got a 0 to 10 volt output, it'll actually use that output. So the last thing I actually got to do is I actually got to use an analog output to control my valve. Now it's going to go into the 0 to 10. There we go. When we open that up, we're going to name this valve. It's going to be an electrical output. I'm going to leave this expander number and output number blank. I'm going to leave network visible off because I don't want to see the network visibility. I want somebody to see my physical I/O. And that's our program. So this is actually a program that will actually modulate depending on fan status, occupancy, and what the temperatures are. So that's how you would set up a direct acting PID microblock inside of Snap. That would be my last program, so hopefully you